Alright guys, so continuing on where we left off in the previous video, I'm going to be talking about what is called as NLTK tokenizing and what is also called as part of speech tagging. So basically this is going to be the first video we are doing as part of NLTK post the installation stage. So this is going to be involving few different concepts which I hope that you guys are paying attention to. Right, the first thing that I want to talk about is called as the tokenizing. What is the process of tokenizing? Now, if any sentence that you take and whatever words that are coming out of my mouth, you are able to process every single word from I am to going, all of that. It's the brain is doing it in a very fast way in terms of getting individual words and processing it and forming the relation between those words and giving you the meaning of that. So technically we are also going to be doing that is the process of tokenizing. So you have any sentences out there and you're going to be breaking these sentences into probably tokens needn't always mean words. They could even mean, I would even show you the exclamatory symbol, the punctuation marks, and all of that can also be tokens. So basically it adds the depth for your sentence. It helps in being the first step for any kind of natural language processing. So you have any sentence, you break it down to tokens first, and that process is called as tokenizing. So I've given you guys what are the different ways of tokenizing that are possible. The first is called as the word tokenizing. My mistake, I've written as work. So it's called as a word tokenizing, sentence tokenizing. There are also a lot of different ways of tokenizing. So most popular one is the word tokenizing, where the algorithm or the layers that we have as part of the machine learning is going to take the first sentence, break it down to multiple words, every single word, and use those list of words and process it and maybe arrive at probably the expression or whatever output you're waiting for. So that also the simplest way to do about tokenizing is to make use of the inbuilt NLTK library itself. NLTK already has the word tokenize method and will automatically take care of doing it. One more important thing I also talked about was that the words needn't always mean token. It can also be punctuation and all of that, but also similarly sentences needn't always be a sentence. It could even be that the sentence or the bigger sentence that you have can have a stop word in between that, and the sentence tokenize method will automatically understand because it has processed so much data, and it also is storing all of those data as part of the word net, and it is able to understand how to split a sentence. So my recommendation is to always use the word tokenize and sentence tokenize that is coming as part of NLTK, and that's what you're going to be writing the first one, the first code as part of this series. So also finally I've written that the use case is to create a pipeline through which these individual tokens can be processed by an ML model, which is what exactly I told, because this is going to be the first step. If you don't tokenize your sentence, you might not have proper output or proper result through your machine learning model. So let's go to the probably the PyCharm. I already have the import NLTK from the previous video, and hope that you guys already have downloaded your NLTK data and your NLTK, and we just get started right away. So let's create a simple sentence. I always like to start with that. Let's say that sentence is going to be this is a coder monk channel, and we are learning to use the NLTK library. Hopefully you all like it. All right, so we have a mixture of things here. I don't made a mistake. You like it. So basically this is the sentence that we have, and we are supposed to now break it down into tokens, and the first method we're going to be using is the NLTK dot word tokenize. And this word tokenize, as soon as you open up the doc string for that, you will see that the doc string takes not just one but two parameters. So if you go inside, you will see that it takes the text and the language, which is very, very important. And that's the powerful thing that NLTK can do. It cannot not just process one language, it can process any kind of language. That is primarily because of the database of things that it holds in the background. So what it does is that it just tokenizes things and sends it out, basically like, splitting words. You will see how it works now. So if you go and give the sentence as the input for the word tokenize, you will find that as soon as I run, you will see that it's splitting individual words. But one more thing you have to understand is that it's not just splitting the words based on the space, which is what most of the people understand it wrongly. It splits it based on the meaning that every single thing may have. So this is the coder monk channel. The comma is also split as a token, and if you go in, you will see that hopefully you will, I've written it as a single word, but the word Tokenize is able to understand that this is not you will, it's not a one word, it's you will. And that's the power of word Tokenize. So basically this is what Tokenize does. And we can even do something called a sentence Tokenize, and you will see that I already have a stop word here, so it should work. If you see that it splits into two lines, one is because of the stop word, it is able to split it into two sentences. So technically how people will do is that they first process it, send it through a sentence Tokenize, and then from the sentence Tokenize they send it to a word Tokenize, so that you have individual words and the algorithm works that way. So probably this is the very basics of things. Hope you guys can run this. And the next thing that I'm going to be showing you guys is called as the part of speech tagging. Now the part of speech tagging is probably the kind of the concepts that I've always wanted to talk. And what this part of speech tagging does is that you have a sentence, and you know that every word in that sentence has some kind of speech. It denotes some kind of part of speech. There could be verb in that, there could be adjective, nouns, adverbs, and all of that. So basically what this the tokenize or the part of speech does is that it takes the individual tokens, and from the individual tokens it tags it as either the word as either is it meaning an adverb, or is it meaning a noun, or is it a verb. And this is a very, very important process, because let's say that I am using the same word as both noun as well as a verb. And how do you understand that? We can understand that, but how will computer understand that? In order to remove the ambiguity of a sentence, it is actually important that we tag individual words as what part of speech that denotes. And I have written here that it is a very important step to determine the tone of a sentence. Now, I can be very sarcastic about something, and I can also say with a straight face, but I can be sarcastic. The tone of the sentence is being matched, or maybe I would say it's being understood only if you are doing a part of speech tagging. And that is also very simple, and it's also a very crucial step as part of any kind of a natural language processing. And you can be doing that with a very simple method, which is also again available as part of the NLTK itself, called as pause tag. Now I'll show you guys how to do the pause tag. First, let's do the word tokenize. Alright, so you can see that I've already printed the word token, but let me assign it to a variable so that I can show you guys how to do the pause tag. So you can say tokens. So I've already split it into tokens, and the pause tag takes into its input as a list of tokens. So what you can do is that you can say NLTK.pause tag, I can say tokens, and it should be a list. If you just pass one word, it will not be able to understand. And if you now see, I'll run it for you guys, and if you see, you might be confused, like what is exactly happening. I'll try to show this here, and you can see that this is the response that comes out. It says this is something, dt is vbc. What exactly does this mean? So basically there are probably 27, if I'm not wrong, 27 different part of speech tags that are available, and the NLTK is able to do that through these tags. Now I'll put the tags that are available right now, the table of tags that are available right now. I'll also give the link in the description for what are the different tags. So basically now read it from here. It is, for example, you say, let's take like an adjective. Now adjective, if you want to say that what is an adjective, it's being denoted by the tag jj. And if you want to say a proper noun, which is a singular proper noun, it is being tagged with probably n and p. Similarly, you have a lot of different ways of saying things. You can have a plural noun. If you want to mark an adverb, it is marked or tagged as rb. So vbp here is marked as the present present tense verb. Similarly, there are different ways through which the tags are marked. You needn't know all the tags, but what happens is that if once you understand how the tagging process works, you'll be understanding the next concepts, which are very, very important. So I'm going to be talking about those, and I'm going to be continuing on in the next video on more about tags and what is the steps that you have to do in processing your data further. So let me meet you there. Until then, Bharat, peace out. Have a super awesome day.